Welcome back, geometry students. This is section 10.3. So just a reminder that this is new material and it is completely optional. So let's get started. This is all about properties of chords. If you remember, a chord is a segment with endpoints on a circle. It's a segment that's going kind of through a circle. It's inside a circle, but the endpoints lie on the edge of the circle. And then we've got 4 new theorems here. Theorem 3, in the same circle or incongruent circle, 2 minor arcs are congruent if and only if. Now remember this if and only if you guys remember that, that's like a double arrow. Okay, it's a biconditional statement. It goes both ways. So, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So, in the same circle or a congruent circle. So let me draw a couple of circles here. Okay. I'm going to say that this radius is 4, and then I'm going to say this chord AB and this chord CD. Now, if I say that this chord is congruent to this chord, okay, obviously that means that chord AB is congruent to chord CD, okay. Also, I know they are in congruent circles because the radius is the same in both circles. So what I can say then is arc AB, that's the minor arc, is also congruent to arc CD. That's what that is saying. And it goes both ways. If I knew the arcs were congruent, then I could also say the chords are congruent. Again, it's a biconditional statement. Okay, if and only if. Theorem 4, if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So if I have a circle, the only way, I can't even seem to draw the diameter, the only way for a chord to bisect another chord, okay, and be perpendicular, so here's my perpendicular symbol, and I'm going to say that this is congruent to this. Let me name these points here, A, B, C. Then, let me call this out here D. Then the first chord is a diameter. Okay, so I know then that DE is a diameter. And you can kind of see there from my beautiful picture that I have it kind of going through the center. Okay, so AB is congruent to BC and DE is perpendicular to AC, so that makes DE a diameter. That's what theorem 4 says. So anytime you have a chord that is perpendicularly bisecting another chord, then that first one has to be a diameter. Okay, that's what that's telling us. Okay, theorem 5. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Now, theorem 5 is kind of, part of it is kind of the biconditional statement of theorem 4. Okay, but it also says and its arc. So kind of back to my picture over here, if I know that this diameter DE bisects AC, then I also know that it bisects the arc. So that means, let me scroll down here a little bit. That means that arc AD is going to be congruent to arc DC. Okay, if it bisects it, it's going to cut the minor arc AC into 2 equal pieces, AD and DC. That's what theorem 5 is telling us. Okay, so again, AD is going to be congruent to DE. Excuse my bad drawing there, but that's what theorem 5 is telling us. Okay. Theorem 6, in the same circle or in congruent circles, again, congruent circles have the same radii, okay, radiuses or radii in the same circle or incongruent circles, two chords are congruent if and only if, there's that if and only if again, okay, biconditional statement, if and only if they are equidistant from the center. So if I have, let me come over here on this side, okay, say, here's my circle, okay. Now say I have this chord, let's call it AB, and let's say I have this chord, let's call it CD, okay. Now, I only know that those chords are congruent if they are equidistant from the center. Now, let me remind you that if you are going to measure distance from a line or a line segment to a point, it has to be measured perpendicularly, okay? Must measure distance perpendicularly, okay? I'm using symbols here. So if I say that this distance here, and I'm going to mark it perpendicular, is 2, and I say that this distance here, again, I'm going to mark it perpendicular, and it's 2, then I can say that segment CD or chord CD is congruent to chord AB. So if they have the same distance from the chord to the center, again, has to be measured perpendicularly, okay? Then I can say that the chords are congruent. And again, it works both ways. If I know the distance is the same, the chords are congruent. If I know the chords are congruent, then the distance is the same. So again, biconditional statement, okay? Works both directions. Okay, so lots about chords, okay? If a chord cuts another chord and bisects it and it's perpendicular, it has to be a diameter. We talked about arcs. If the chords are congruent, then in congruent circles are the same circle, then the arcs are congruent, all that good jazz. So let's look at example 1 here. In the diagram, circle A is congruent to circle B. Chord CD is congruent to chord EF. You can see that marked there with the double. Okay, these are congruent. All right. And measure of arc CD, that's this measure, okay, is 140. So find the measure of arc EF. Well, again, if the chords are congruent, the arcs are going to be congruent. So we know that arc CD is congruent to arc EF. So just like they said then, the measure of arc EF has to also be 140 degrees. Okay, so let's go down and look at some of these exercises here. For example 1, use the diagram of circle K. If measure of arc GH is 100 degrees, so we're talking about this being 100 degrees, find the measure of arc IJ. Now, because these are congruent, if that's 100 degrees, then this also has to be 100 degrees. Okay, I hope that makes sense. Then it says if measure of GI is 55 degrees, so if this is 55 degrees and HJ, actually let me erase this because I don't think that's going to hold true on this one. And HJ, sorry, is 115. Okay. Find measure of GH. Well, let's just label it here. If GH is X, then wouldn't IJ also be X? So then our equation here for number 2 is going to be 55 plus 115 plus 2 X's equals 360. Do you all see that? Okay. Here's my work for number 2. So we've got the 15 degrees, we've got the 115 degrees, and then we've got 2 X's. I know that IJ has to be congruent to GH, the arcs, okay? So that's where the 2X comes in. So this gives me 2X equals 190, if I take 360 minus 115 minus 55. So x equals 95. Now, does that answer the question they asked? Find the measure of arc GH. Yes, it does, because measure of arc GH is just one of the x's. So this is 95 degrees. Okay, hope that makes sense. Let's look at number 3. If measure of IJ, now I'm going to erase my markings on here and kind of start over, okay? If measure of IJ is 85, so this is 85 degrees, okay? That also means then that GH is also 85 degrees, okay? And HJ is 120. So if this is 120, find measure of GI, okay? So essentially, my equation is going to be, I'm going to call this my x then, okay? So 2 times 85 plus 120 plus x equals 360. We can solve that, okay? I think I hit another little dead spot here. So if we do our math, we should get x equals 70. Okay. All right. Now, this example 2, this is kind of tricky, I think. So I did definitely want to walk through this one. Says 3 baseball players stand in a field as shown. Where should a 4th player, player X, stand if he wanted to throw the ball the same distance to each player? Okay, so you want some point out in here to be an X, to where you want this to be congruent, to this to be congruent, to this to be congruent. Okay, how do you get that point? Okay, how do you get that point that would be equidistant to R to S to T? Well, let's look at the second page here. Here's the process. So they're going to use that theorem 4. Remember, theorem 4 says if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. Okay, so it says draw the perpendicular bisectors of RS and ST. By theorem 4, these are diameters of the circle containing R, S, and T. Okay, so those are diameters. So they would just keep going. Okay, this would be a really big circle. Okay, because what this is going to end up being, this is going to be the center of the circle that houses points R, S, and T on its outside. Okay, so find the point where these bisectors intersect. That's step 3. This is the center of the circle containing R, S, and T. So it is equidistant from each point. If that's the center, and if R, S, and T are on the circle, then this is the radius, this would be a radius, and this would also be a radius. Okay, so obviously these would all be congruent because they would all be radii of the circle. Okay, that's where they get that. Okay, so look at exercise for example 2. 3 cities are located on a map as shown. A wireless communications company plans to build a relay tower to provide cell phone service to each of the cities. In order to provide the cities with a signal of equal strength, the tower must be placed equidistant from each. Show and explain how this location can be determined. So again, just like the example we did above it, if I draw a line from A to B, I should say line segment, from B to C and A to C, I would need the perpendicular bisector of each of these. So I'm just going to kind of eyeball it here. If I draw the perpendicular bisector here, I draw the perpendicular bisector here, and I didn't draw this very well. I draw the perpendicular bisector here. Where they all meet, that's where the tower should be. Okay? So when I said bisector, like those two should be equal, those two should be equal, those should be equal. Okay, so this right here would be my center. That would be my tower. So again, same explanation as the one right above. Okay, now using diameter. In circle A, find the lengths of CJ and AK. Now we're talking segments here. Given that the length of BC equals the length of FG, which is 16. So let me first mark that. So BC, this whole segment is 16, and that is congruent to FG, which is also 16. Okay, and AJ, this little part in here, it says is 5. Okay, first of all, the first thing that jumps out at me is AK. Okay, if BC is congruent to FG, then that means they are equidistant. They're the same distance from the center. So if AJ is 5, that means that AK is 5. Okay, that's the first one that jumps out at me just by looking at my colors here. And CJ, okay, since DE is obviously a diameter, DE is cutting through a chord. Remember, it's going to cut through it perpendicularly, but it also means that those two pieces, that BJ must equal CJ, okay? Because DE is a diameter. So if it cuts it perpendicularly, it's going to also bisect it, okay? So that means that CJ has to be 1/2 of BC, which is what they did up here, okay? Which is 8. All right. Okay, now let's do some more exercises below it. Oh, we're supposed to use the diagram now from example 3, right above it. So measure of arc BD. First of all, I'm going to erase this so we can add more to it here. So find the measure arc of BD if CD equals 4x. Okay, so first of all, if CD, this right here, is 4x degrees, and the measure of BD is 2x plus 40. So BD here, 2x plus 40. Now, what do we know to be true about the arc of BD and the arc of CD? Remember, we had that theorem that said, Theorem 5, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So that means that BJ is congruent to CJ, and that means that this has to be congruent to that. Okay, so we have 2x plus 40 has to equal 4x. So that means 40 equals 2x, 4x is 20. Now, that doesn't answer the question. It says find the measure of BD. Well, the measure of arc BD is 2x plus 40. Well, my x, okay, is 20. So 40 plus 40, 80 degrees. That would be my answer there for number 5. I hope you guys saw that. So again, if you have a diameter that's perpendicular to a chord, then it bisects the chord and its arc. Okay. Okay, find GK if BC equals FG equals 20. So BC equals FG. Again, those are those two chords. BC and FG are both 20. Okay, so find GK. Find GK. Well, how do we go about doing that? If we're finding GK here, if AD bisects BC, then AK is also going to bisect because it's perpendicular. Okay, let me draw this here. AK, notice it's perpendicular. They have that marked. If I extend that, because it hits the center, that is going to also be a diameter. Okay, so that means it's going to bisect FG. So AK bisects FG. Okay, so if it bisects FG, then that means that GK equals 1/2 of FG, which is 1/2 of 20, or 10. Okay, I hope you see that. AK is also, if you extend it, since it hits the center and it's perpendicular, it's also a diameter. Okay, so that means that it's going to bisect the chord and the arc, but in particular the chord. Okay, I hope that makes sense. All right, let's move on to practice A. Okay, going to do a couple of these from each section. Find the chord length. Okay, now remember all the stuff we've learned about chords here in the study guide. If this arc is 155 and this arc is 155, then if the length of this one is 9, if this is 9, then that means this also has to be 9. Okay? If the arcs are the same, then the chords are the same. KM. Okay, first of all, JK looks like the whole, sorry, JL looks like the whole thing is 8. That's 5 plus 3. Okay. So the other thing that I notice here is that this is congruent to this. Now they're just talking about this arc and this arc. Okay. They both share, whoops, wrong color. They both share this arc. Okay. So KM is also the blue plus the purple, like JL is the blue plus the purple. So that means that KM is also 8. I hope you guys see that. Okay. So 5 and 3, this would also be 5 and 3. Okay. Number 5, measure of arc TU. Okay, first of all, this 85 right here is a central angle. Okay, so if this is 85, that means the arc RS is 85. Measure of arc RS is 85, because remember your arc measure is the same as your central angle. Well, the other thing we know here is that if this chord is congruent to this chord, then remember if the chords are congruent, the arc measures are congruent. So measure of arc TU is also 85. Okay, hope that makes sense. Moving right along. Tell whether QS is a diameter of circle C. If not, explain why. This one, is it a diameter? Now, I want to remind you of the theorem here. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. That is theorem 4. Okay, so I think we could agree that this is a perpendicular bisector. Okay, so I would say yes, it is both perpendicular and it bisects. Okay, and they didn't really ask for the explanation if it doesn't, but I did it anyway. Number 10, moving right along, tell whether the measures are equal. Now, LK and KN. It doesn't tell us anything about the lengths of LK and KN. It does tell us that this is perpendicular, but what we don't know is where the center of the circle is. So I can honestly say there is not enough information. Okay, what we don't know is if MP goes through the center of the circle. Okay, or you could alternately say we don't know if MP is the diameter. Okay, if it goes through the center, if we know it's the diameter and it's perpendicular, then yes, it will bisect. But I don't know that it went through the center, so I can't say for sure that it's a diameter. Okay, it's a little easier to see if I would have drawn MP over here and said, yeah, that's perpendicular. If I don't know that it went through the center, I can't say it bisects it. Okay, so I hope that makes sense. Okay, 12, measure of arc BC and measure of arc CD. So we're supposed to see if these are equal. First of all, we have this. We can say that that is a diameter. So if that's a diameter and it's perpendicular, then I know that those are bisect. And again, we've got that theorem, okay, that says if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So that means that BC would be congruent to CD. Okay, so that would be a yes. Okay, all right, moving along. Find the given measure. So number 13, measure of BD. Okay, first of all, we know that this is a diameter because we can see that it goes through the center A. Okay, and we know it's perpendicular. So we've got that theorem that says if we have a diameter that's perpendicular to a chord, okay, it also bisects the chord and it bisects the arc. So if this is 5, this is 5. So BD, would equal 10. Okay, hope that makes sense. Next page. So tell whether the lengths are equal. So we're comparing CD and EF. Now, we know here from the center, we know that they're perpendicular and they're congruent. So again, we have that theorem that says in the same circle or incongruent circle, two chords are congruent if and only if they are equidistant from the center. So the distance was measured perpendicularly and the distance is the same. So I can say, yes, those lengths are equal, absolutely. Number 18, can I say those lengths are equal? That would be a no. And I was comparing TQ here to UQ, okay? I don't know that because it's not perpendicular. Okay, if it's not perpendicular, then I can't say those are congruent, okay? The chords may be congruent, but it wasn't measured perpendicularly to the center, so I can't say that the distances are congruent. Find the given measure. So look at number 20 there. Again, we're trying to find the measure here of HJ. So we're trying to find the measure of this. Well, if this is 4 and this is 4 and they're measured perpendicularly, then that means the chords have to be the same length. So yes, that is 7. 22, find the value of X. So again, we've got a diameter and it's perpendicular. So if a diameter intersects a chord at a 90-degree angle, then that means it bisects the chord and the arc. But in this case, that means that 6x plus 1 would have to equal 8x minus 5. Okay, so 6 equals 2x, x equals 3. Okay, hope that makes sense. And number 25, you notice that the word liberty That's this word right here. Okay. On the head side of a quarter makes the same arc as the words quarter dollar on the tail side. Explain how you can use a straight ruler to check this is true. Okay. So here's the quarter dollar down here. Okay. So actually let me highlight the arc. So we're talking about this arc and we're talking about this arc. So here's how we would do this. Essentially, use a straight edge, measure this length, and measure this length. Are those congruent? If those are congruent, then the arcs are congruent. Okay, that's what you would be doing. You could explain that a little better in words, but if you measure like from the L to the Y, okay, and get that straight chord length, and then you measure from the Q to the R and get that straight chord length, those are congruent. Obviously, the front and back sides of a quarter are going to be congruent circles, right? It's the same physical thing. So congruent circles. So if the chord lengths are congruent, then that means the arcs are congruent. Okay. All right. That concludes 10.3. And hope you guys are doing well. I will record 10.4 shortly.